when it hits the Earth, it can cause a lot of damage because the crater that's produced is typically 10 or 20 times the width of the incoming object. So that would be 1,000 or a few thousand feet. And many miles surrounding the impact region are affected by all the debris that gets ejected. You'd have all this stuff raining down upon you.
But even if the asteroid hit hundreds of miles from the city, it could still create chaos for the millions of people living there. The food supply for the city residents could be drastically altered if the asteroid hit a major agricultural area nearby.
Not only would all of the humans there be very likely dead, but it would sear hundreds of square miles of the growing lands. It would destroy all the current crops, and it would render the area pretty unusable for quite a period of time.
And smaller asteroids don't even need to impact the ground to cause widespread destruction. In 1908, an airburst from an asteroid that broke apart in the atmosphere leveled an estimated 80 million trees over hundreds of square miles near the Tunguska River in Siberia.
When an asteroid or a comet is coming toward the Earth, it first encounters the atmosphere, and it squeezes it, it compresses it, and that pressure causes the asteroid or comet to explode. That explosion then spreads the energy over a vast region of the ground below it. So these atmospheric airbursts are very dangerous as well.
But the rock that caused all of that destruction may have been even smaller than first thought. When it hit the atmosphere, the Tunguska object may have been only a few dozens of yards across, instead of hundreds of yards, as originally estimated.
At first, it may seem like a good thing, Tunguska smaller than we thought, but it's actually a bad thing for our future predictions, because there are more smaller objects than larger ones. So if a small object can cause that much damage, then that means it's going to happen more often than if it were a big object. We may have that impactor every few hundred years instead of every few thousand years.
At the really small end of the scale, below about 100 feet, space rocks are often known as meteoroids instead of asteroids. Shooting stars are caused by meteoroids burning up in the atmosphere. They're sometimes captured by amateur cameras, with some small chunks hitting the ground or even cars or buildings. In fact, the Earth's atmosphere is pelted with objects from outer space far more often than most people realize.
I'm here at this active rock quarry next to this big pile of crushed rock because this is about the amount of stuff, the amount of dust and sand and pebbles that hit the Earth's atmosphere every day, about 100 tons. That's enough to fill about 6 or 7 of these dump trucks. Now down here we've got a basketball-sized rock. On average, about 2 of these slam into the Earth's atmosphere every single day. Next is the small car-sized object. Imagine this pile of rocks as one object slamming into the Earth's atmosphere, about the size of a small car. This happens about once every 2 weeks, but even something this big is probably going to burn up completely before reaching the Earth's surface. For a typical object hitting the Earth's atmosphere, it needs to be at least 100 feet in diameter to actually do serious damage to the surface. Now 100 feet is a really big rock. That's like going from the front of the dump truck over there all the way to that orange cone over there.
At the other end of the spectrum is Earth's largest confirmed impact crater. Located in Vredefort, South Africa, it stretches more than 180 miles across and drastically changed the ancient Earth when it hit about 2 billion years ago.
it would have sent a sheet of material into space, which would then have come back and impacted on the Earth, ignited fires if there was anything to burn. And the climactic effects from that impact would have lasted for decades. The oceans would have been completely acidified. There would have been tons and tons of soot up in the atmosphere. And so that is something that we really would not want to see happen.
For the primitive life on Earth at the time, it was a major extinction event, with a crater more than 1.5 times larger than the one that wiped out the dinosaurs. The South African crater wasn't discovered until the 1990s, since most of its features had eroded in the last 2 billion years. But photos from space revealed its existence. A hilly region in the center of the deep crater initially had scientists thinking that there'd been volcanic activity in the area. But it's actually what's known as a central rebound peak, a distinctive feature for craters about 100 miles wide or larger.
As you get to larger sizes, the energy of the impactor is so high that when it comes in, the rock essentially acts like it has no strength. Then what you get is something very much like when you drop a pebble in water and you see that rebound peak as the water fills in, comes back up. But since it is rock, it then solidifies. And we see lots of these central peaks on the moon and elsewhere in the solar system.
But there are other large asteroids that have hit much more recently. Even more recently than the dinosaur-killing asteroid from 65 million years ago. 30 million years later, another massive asteroid pummeled the east coast of America and helped form what is now Chesapeake Bay.
We see evidence of debris from that impact all the way up and down the eastern seaboard, all the way up to New Jersey, New York, and comparable on the south end of it.
The 55-mile-wide crater was hidden from view underwater until oil exploration confirmed its existence in the 1990s. And since the asteroid hit just offshore, it created a massive tsunami.
Some say that the waves could have been 10, 20, maybe even 30 miles high. That's a big wave. The Appalachian Mountains are only a few thousand feet high, so even though a lot of the wave was diminished as it went inland, that's a lot of water, and it could well have flooded over the Appalachians and into what we now think of as the Ohio River Valley.
And if that same impact happened today, the East Coast would never be the same again. An asteroid attack has the power to instantly kill millions of people. The largest impacts can also cause global catastrophes, threatening the very existence of mankind. That's why the study of asteroids is one of science's highest priorities. 35 million years ago, an enormous asteroid slammed into America's east coast. The 55-mile-wide crater was hidden until recently, under Chesapeake Bay. Its effects were devastating. But what if that same impact happened today?
It would wipe out the East Coast essentially through a combination of tsunamis, blast waves, thermal effects, and it would also throw out huge amounts of ejecting that would spread to great distances, igniting additional forest fires.
It would be millions of people instantaneously killed or shortly after the impact. But it would have farther-reaching consequences, too, because of the overriding disruption throughout the entire region. Farming, communication, certainly our center of our government is on the East Coast.
But according to recently uncovered fossil records, the 1-mile-wide Chesapeake Bay asteroid didn't seem to have the same global effects as the massive extinctions triggered by the 6-mile asteroid that killed the dinosaurs.
The impact that created the Chesapeake Bay structure more than 30 million years ago was enormous, but it was still only a small fraction of the energy that was released during the impact in the Yucatan 65 million years ago. The impact was right on the threshold of providing truly global effects. Right on the threshold of what's required to make a mass extinction occur.
Because of that destructive power, it's crucial to know exactly what we're dealing with. And that means getting up close and personal. In 2001, the NASA mission named NEAR was supposed to just orbit the asteroid Eros.
But once it had got there and it had completed its mission objectives, the decision was made, let's try to land this thing, which is really, really fun. It's kind of old-fashioned exploration. Hey, go ahead and give it a try. So they did.
The images from the approach and landing gave scientists a much more detailed look at the surface of an asteroid than they'd ever had before, with some unexpected results.
One of the surprises looking at these small bodies is that they have geology. It had tectonic features and looks like it had landslides and erosion happening on its surface and impact craters all over it and boulders everywhere. And one imagines the scenario where a little asteroid comes along and hits a bigger asteroid, crashes into it, digs up a whole bunch of debris, and that slowly settles down and these boulders just spread across the entire surface.